Welcome back guys. Welcome back to another video session from this channel. So in this video session we will be studying regarding the regulation of kidney function and as well as the micturition reflex activity in detail. So here the regulation of the kidney function, it is efficiently monitored or it is efficiently regulated by taking the advantage of hormonal feedback mechanism. So here the hormonal feedback mechanism of various organs like hypothalamus, juxtaglomerular apparatus and even the heart, they play an important role. So what it is? Hormonal feedback mechanism. Hormonal feedback mechanism is required. So the various organs which participate or which induces the hormonal feedback mechanism include hypothalamus, juxtaglomerular apparatus and the other one is heart. Hypothalamus, juxtaglomerular apparatus, which is simply abbreviated as JGA, and the other one is heart. So at first we will be studying regarding the activity of hypothalamus. How the specific hypothalamus, it is responsible for regulating the kidney function so efficiently. So here, as I have already mentioned you earlier, under humid conditions, once when the levels of water decreases gradually in the body, now here the volume of the blood in the body, it also decreases. So once when the volume of the blood in the body decreases, now here the osmoreceptors, which are a part of the hypothalamus of the forebrain, they undergo activation, and these specific osmoreceptors, they are responsible for triggering or for activating the posterior pituitary. And here the specific posterior pituitary, it is responsible for secreting a specific hormone which is nothing but vasopressin or antidiuretic hormone. Now the specific vasopressin or antidiuretic hormone, it is responsible for regulating the water reabsorption in case of the distal convoluted tubule. That means in most of the times the water reabsorption, it is observed only in case of the proximal convoluted tubule. So the specific water reabsorption which is observed in case of the proximal convoluted tubule, here it is termed as what? Obligatory water reabsorption. So here the obligatory water reabsorption, it is a mandatory mechanism or it is a mandatory process, but whereas the specific facultative water reabsorption which is successfully organized by taking the advantage of vasopressin or antidiuretic hormone in case of the distal convoluted tubule, it is not a mandatory mechanism. So let me write it on the board. What it is? Osmoreceptors of the hypothalamus of the forebrain, they trigger posterior pituitary. Posterior pituitary, it is responsible for secreting vasopressin or antidiuretic hormone. So here the specific vasopressin or antidiuretic hormone, it is a strong potent vasoconstrictor. So in the presence of vasopressin or antidiuretic hormone, the water reabsorption, even it is observed in case of the distal convoluted tubule, and here it is termed as what? Facultative water reabsorption. So once when the water reabsorption, when it reaches to the extreme levels, and once when the water levels in the body, when it increases gradually, now here the specific osmoreceptors initially, which is under switch on mode, now here they become switch off. So once when the osmoreceptors, once when they become switch off, now here the specific water reabsorption, it successfully inhibits here. So here, as I have already mentioned you, the specific vasopressin or antidiuretic hormone, it is not only responsible for regulating the water reabsorption in case of the distal convoluted tubule, and in addition the specific vasopressin or antidiuretic hormone, it is a strong, powerful or it is a strong, potent vasoconstrictor. That means in the presence of vasopressin or antidiuretic hormone, the walls of the blood vessels, they become so narrow, or the walls of the blood vessels, they become so constricted. So once when the walls of the blood vessels, once when they become so constricted, now here it in turn, it increases the blood pressure. So once when the blood pressure increases, now even the glomerular filtration rate, it also increases. Is it clear? So let me write it on the board. Glomerular filtration rate increases in the presence of vasopressin. So in this way, the specific hypothalamus, it is responsible for regulating the kidney function so efficiently. Then after, we will be studying regarding the activity of juxtaglomerular apparatus. So how the specific juxtaglomerular apparatus, it is responsible for regulating the kidney function so efficiently. Is it clear? So let me arrange the things first. So the next specific component which is responsible for regulating the kidney function so efficiently, here it is nothing but what? Juxtaglomerular apparatus. What it is? Juxtaglomerular apparatus. So here the juxtaglomerular apparatus, it is responsible for regulating the RAS mechanism. RAS mechanism. So here, prior to the explanation of the RAS mechanism in detail, at first let us have a look on the specific juxtaglomerular apparatus. So here the juxtaglomerular apparatus, it is an association of juxtaglomerular cells and the other one is macula densa of the distal convoluted tubule. What it is? Juxtaglomerular cells and the other one is macula densa of distal convoluted tubule. So at first, if we consider the juxtaglomerular cells, so what are juxtaglomerular cells? As I have already mentioned you, in case of the particular glomerulus, here there is an availability of two specific blood vessels. What are those? Efferent renal arteriole, which is having the wider diameter, and the other one is efferent renal arteriole, which is having the narrow diameter. So here on the interior side of the efferent renal arteriole, so here the smooth involuntary muscles are present. So here the smooth involuntary muscles, they are composed of juxtaglomerular cells. So here these specific juxtaglomerular cells, which are a part of smooth involuntary muscles of the specific efferent renal arteriole, they are responsible for secreting a specific hormone, which is nothing but what? Renin. Juxtaglomerular cells, they are a part of efferent renal arteriole. Efferent renal arteriole. So here the specific juxtaglomerular cells, they are responsible for secreting the renin hormone. Then what about the specific macula densa? So here the specific macula densa, it is a component of, or it is a part of distal convoluted tubule. So here if we consider the transverse section of the distal convoluted tubule, so here let us assume it as the transverse section of the distal convoluted tubule. So here, as I have already mentioned you, the particular distal convoluted tubule, it is composed of cuboidal shaped cells. So here the specific part of the distal convoluted tubule which successfully exposes towards the medullary region, it is composed of cuboidal shaped cells. Cuboidal shaped cells, right? And here the other part of the particular distal convoluted tubule which successfully exposes towards the glomerulus, they are composed of specific columnar cells. What it is? Columnar cells. All these are the columnar cells. So these columnar cells, they are termed as what? Macula densa. So here the specific macula densa, which is a part of the distal convoluted tubule, it is responsible for detecting the low levels of osmolarity. So here once when the levels of the osmolarity, when they decreases gradually, or once when the levels of water in case of the particular body, when it is under low condition, under such condition, the specific macula densa, which is a part of the distal convoluted tubule, it undergoes activation. Now the specific macula densa, it in turn, it triggers or it activates the particular juxtaglomerular cells. Now the specific juxtaglomerular cells, they are responsible for secreting a specific hormone which is nothing but what? Renin. So here, as I have already mentioned you, the particular juxtaglomerular apparatus, it is responsible for regulating the specific RAS mechanism. So here RAS stands for what? R stands for renin, A stands for angiotensin, and the other A stands for aldosterone, and the other S stands for what? System. Is it clear? So here it is simply abbreviated as what? RAS mechanism. So here the specific RAS mechanism, it is successfully organized by taking the advantage of juxtaglomerular apparatus. So here, once when the particular juxtaglomerular cells, once when they undergo activation under the supervision of macula densa, now here the specific juxtaglomerular cells, they are responsible for secreting the specific renin hormone. Now here the specific renin, it is responsible for converting the specific angiotensinogen of the particular liver cells. Is it clear? So let me write it on the board. Liver, it is responsible for synthesizing or for secreting angiotensinogen. But the particular angiotensinogen, it is under inactive mode. Inactive mode. Now here the specific angiotensinogen in the presence of renin, it successfully converts into angiotensin 1. Angiotensin 1, which is an low potent vasoconstrictor. Low potent vasoconstrictor. Now here the specific angiotensin 1 in the presence of angiotensin converting enzyme, which successfully synthesizes by the lungs. So here it is responsible for the conversion of angiotensin 1 into angiotensin 2. Angiotensin 2. So in comparison with the angiotensin 1, angiotensin 2, it is a strong potent vasoconstrictor. So here, as the name itself suggests, so here the specific angiotensin 2, it is responsible for inducing the specific vasoconstriction. That means in the presence of angiotensin 2, the walls of the blood vessels, they become so narrow or they become so constricted. So here the specific angiotensin 2, which successfully forms in the presence of angiotensin converting enzyme, it is responsible for triggering or for activating the adrenal cortex. As we all know, on the outer surface of the particular kidneys, here there is an availability of the specific gland, which is nothing but what? Adrenal gland. So here the specific angiotensin 2, it is responsible for triggering or for activating the adrenal cortex. So once when the adrenal cortex, when it activates, now here the specific adrenal cortex, it is responsible for secreting a specific hormone, which is nothing but what? Aldosterone. So let me write it on the board. Angiotensin 2, it is responsible for triggering or for activating the adrenal cortex, and the specific adrenal cortex, it is responsible for secreting the aldosterone. So what is the role of aldosterone here? The specific aldosterone, it is responsible for regulating the water reabsorption in case of the distal convoluted tubule. Is it clear? The specific aldosterone, it is not only responsible for regulating the water reabsorption in case of the distal convoluted tubule, and in addition, the particular aldosterone, even it is responsible for regulating the reabsorption of sodium in case of the distal convoluted tubule. Is it clear? So in this way, the particular juxtaglomerular apparatus, it is responsible for regulating the blood pressure, and even it is also responsible for regulating the water levels in case of the body. Is it clear? So then after we will be studying regarding the specific atrial natriuretic factor, which successfully synthesizes by the walls of the human heart. So the next specific factor which is responsible for regulating the kidney function so efficiently, here it is nothing but what? Atrial natriuretic factor. Atrial natriuretic factor, which is simply abbreviated as ANF. So here the specific atrial natriuretic factor, it successfully synthesizes by the walls of the human heart. And here the specific atrial natriuretic factor, it is an antagonistic of the particular RAS mechanism. So here the juxtaglomerular apparatus, it is responsible for regulating the RAS mechanism, but whereas the specific atrial natriuretic factor, which successfully synthesizes by the walls of the human heart, it acts as an antagonistic of the RAS mechanism. It acts as antagonistic of RAS mechanism. So here in general, the particular juxtaglomerular apparatus, it is responsible for regulating the water reabsorption and as well as the sodium reabsorption from the distal convoluted tubule. But whereas the particular atrial natriuretic factor, in general, it activates under very high blood pressure. So here in order to overcome the very high blood pressure, so here the specific atrial natriuretic factor, it is responsible for suppressing the RAS mechanism. In the presence of atrial natriuretic factor, the specific sodium ion and as well as the water, instead of undergoing reabsorption from the distal convoluted tubule, they undergo secretion. So once when the sodium ion and as well as the water, once when they undergo secretion instead of undergoing reabsorption, now here the specific atrial natriuretic factor, it is responsible for lowering the blood pressure. So let me write it on the board. Atrial natriuretic factor, it is responsible for inducing the secretion of sodium and as well as water. Sodium and as well as water from the distal convoluted tubule. And even it is also responsible for lowering the blood pressure. Is it clear? So here all these are the various factors or all these are the various organs which are responsible for regulating the kidney function so efficiently. Then after we will be studying regarding the mechanism or the process of micturition in detail. So what is micturition? We will be studying regarding the micturition mechanism. Micturition. So what is micturition here? So here the concentrated urine or the hypertonic urine which successfully forms in case of the kidneys because of the counter exchange of ions or electrolytes. Now the concentrated urine or the hypertonic urine, it successfully transports from the kidneys to the urinary bladder by taking the advantage of pair of ureters. Now the specific urine which successfully reaches to the urinary bladder. Now here the specific urinary bladder, it acts as a temporary storage for the human urine here. Is it clear? So here the mechanism or the process through which the concentrated urine which successfully stores in case of the urinary bladder, it is capable to excrete outer side. So here the mechanism or the process through which the concentrated urine which remains in case of the urinary bladder, it is capable to excrete outer side. Here it is termed as what? Micturition. Is it clear? So here if we consider the human urine is pale yellow in color. And if we consider the pH of the urine is acidic pH. And on average, one human excretes around urine excretion is around 1.5 liters of urine. 1.5 liters of urine. And even an human excretes around 25 to 30 grams of urea per day. Is it clear? So in general, the human urine which successfully stores in case of the urinary bladder, it is capable to come outer side by taking the advantage of, by the means of a specific mechanism which is nothing but what? Micturition. So here how the specific micturition mechanism or the micturition process it is successfully organized here. On the surface of the urinary bladder, certain receptors are present, and these receptors they are nothing but what? Stretch receptors. So let me write it on the board. Stretch receptors. And if we consider the maximum capacity of the urine in case of the urinary bladder, it is around 150 to 500 ml of urine. So once when the specific urine, when it reaches to the extreme levels, under such condition, on the surface of the urinary bladder, stretch receptors are present. So these stretch receptors, they are responsible for triggering or for activating the sensory nerves. So here, what are sensory nerves here? The specific nerves which are responsible for carrying the information from the effector organ to the brain. Is it clear? The specific nerves which are responsible for carrying the information from the effector organ to the brain. So specific nerves they are termed as what? Sensory nerves. So initially stretch receptors are activated. So these stretch receptors in turn they trigger or they activate the sensory nerves. Sensory nerves. So these sensory nerves, so they trigger or they activate the human brain. So in turn, from the human brain, the information it is carried out or it is induced by taking the advantage of motor nerves. So what are motor nerves? The specific nerves which are responsible for carrying the information from the brain to the effector organ. So such specific nerves they are termed as what? Motor nerves. So here the specific motor nerves they are responsible for triggering or for activating the specific detrusor muscles which remain on the surface of the urinary bladder. Is it clear? So let me write it on the board. Motor nerves are responsible for triggering or for activating the detrusor muscles. Detrusor muscles which remain on the surface of the urinary bladder. So here the specific detrusor muscles they undergo contraction. That means the walls of the urinary bladder they undergo contraction once when the specific motor nerves, once when they induce the information from the brain to the effector organ. So once when the specific urinary bladder, once when it undergoes contraction, under such condition the urine which stores in case of the urinary bladder, it is capable to excrete outer side from the urinary bladder to the urethra. Is it clear? So likewise the urinary bladder, even the specific urethra, it possesses certain muscles, and here these specific muscles they are termed as what? Urethral sphincter muscles. So let me write it on the board. Urethral sphincter muscles. So here the specific detrusor muscles they undergo contraction, but whereas the urethral sphincter muscles they undergo relaxation. So once when the urethral sphincter muscles, once when they undergo relaxation, now the urine which stores in case of the urinary bladder, it is capable to come outer side. So here the mechanism or the process through which the urine which stores in case of the urinary bladder, it is capable to come outer side. Here it is termed as what? Micturition. Is it clear? Various adverse conditions they can affect the chemical composition of the human urine. That means by taking the advantage of the chemical composition of the human urine into consideration, we can analyze the health status of an individual. That means if we consider the presence of glucose in case of the human urine, it indirectly suggests or it indirectly says that the particular individual is suffering from a metabolic disorder which is nothing but what? Glycosouria. That means in general the glucose levels they are completely absent in case of the human urine. But once when the glucose levels, once when they are observed in case of the human urine, it indirectly suggests or it indirectly says that the particular individual is suffering from a metabolic disorder which is nothing but what? Glycosouria. In the same way, if we observe the presence of the various ketone bodies like acetone, acetoacetate and beta hydroxybutyrate in case of the human urine, it indirectly suggests or it indirectly says that the particular individual is suffering from a metabolic disorder which is nothing but what? Ketouria. Is it clear? So here this is regarding the regulation of the kidney function and as well as the micturition reflex activity in detail. So here I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.